Hi everyone, let's discuss one example problem related to additions of a system of coplanar forces. This example problem is the same as the one that we discussed in lecture 2 when we talk about parallelogram law and triangle rule in doing the vector operations. So instead of using those two methods in here, we are going to use the topics that we just learned in lecture 5, which is basically utilizing the two-dimensional Cartesian components of force vectors. Okay, so in here it's always a good idea to list it out what is the given informations when we try to solve problems. And so in these problems, if we try to recall, we know that F1 is equal to 1 pound, F2 is equal to 2 pound, okay, and alpha is equal to 30 degree, beta is equal to 45 degree, okay. And then in here we have to find what is the vector summations and vector difference, but in these lectures I will just demonstrate how we can calculate the vector summations and also theta as x, which is the angle made between the vector summations to the horizontal axis. Okay, so let's perform the calculation. Okay, it's always a good idea to resketch everything. Okay, so this is my x-axis, this is my y-axis, okay, and then I have my force F1 right there, okay, and then I have my force F2 right there, okay. And if you remember, the resultant vector that we obtained is somewhat going to these directions, okay, in which this angle right here is what we call as theta as x, okay. So the first thing that we have to do is to find what is the Cartesian component of these force vectors right here, right? We have F2x and F2y, and in red we have F1y and F1x, okay. And we can calculate here F1x is basically, this angle is alpha, right? Is F1 cosine alpha, F1y is F1 sine alpha. However, the sign is negative in here because F1y is going to the negative y direction, okay. So plug in the value. F1 is 1 pound, this is 30 degree, this is 1 pound, right? Alpha is 30 degree. We perform the calculations. We will obtain that F1x is 0.866 pound and F1y is negative 0.5 pound, right? So in blue we are going to calculate the Cartesian component of force vector F2. So in the problems it's given that this is beta, right? So F2x is F2 cosine beta, F2y is F2 sine beta, okay. So we know F2 is 2 pound, right? Beta is 45 degree. So we can plug in the numerical value and calculate that F2x is equal to 1.414 pound. Similarly, the F2Y is 1.414 pound, and both are positive because we can see that F2X and F2Y over here is pointing to the positive X and Y direction respectively. Okay, so we know that Fs, okay, is F1X plus, I'm sorry, is F1 plus F2, right? And we can write F1 in here is F1X I plus F, let's use red color since such that is consistent with what we are doing before. So F1X I plus F1YJ, right? F1YJ, and in blue plus F2XI plus F2YJ. Okay, taking the same I component in here and the same J component in here, okay, I can write F1X plus F2X I plus F1Y plus F2Y J. Okay, I have calculated what is F1X, F2X, F1Y, F2Y. I just can plug in the numerical value in here. I will obtain that F1X is equal to 2.28 I plus F1Y plus F2Y is 0.914 J, and these whole things are in pound. Okay, so that's Fs, and we can calculate the magnitude of Fs by taking the square root of its component, 2.28, I mean square root of the sum of the squares of its component plus 0.914 square. Okay, and in here we will obtain 2.457 pound. Okay, and it's the same as what we have calculated before, right? And notice that if we go back to this figure right here, this is theta as x, and if I can sketch in green, okay, note that this is f as y and this is f as x, right? So tangent theta as x is f as y divided by f as x. So when you formulate this expression, it's always good to sketch it first, okay? Because in here basically we are using this right triangle over here, okay, to calculate what is the theta as x. Okay, so we know that from this expression theta as x is tangent inverse of f as y divided by f as x. So I know what is f as y. This is f as y, this is f as x. Okay, then taking the calculations, I obtain 21.847 degree. All right, so that's it for this example, and in the class I hope we have time to calculate what is fd and theta dx. All right, thank you.